two different ways of graphing this. Let's do one with asymptotes. If you studied asymptotes before, one of the rules is that if the power is smaller in the top than it is in the bottom, then it has a horizontal asymptote always at y equals 0. And that's the case here. Because the power on the top is x to the 0. There's no x there. Power on the bottom is x to the first. And whenever that happens, y equals 0, this black horizontal line that I'm drawing is always an asymptote. Oh, you get the idea. Going straight across there. And then the other asymptote we should look at is a vertical asymptote. And those always occur where a divide by 0 problem happens. And if you plug in x equals 6, you have a divide by 0 problem. So at x equals 6, I know I'm never going to touch this vertical black line. So we got these two asymptotes that we need to take care of, and we never should cross. Our graph is going to look something like this, because a reciprocal function should always look something like that. Like the basic reciprocal function f of x equals 1 over x, that looks like this. So this is really similar, it's just been transformed a few spaces. It's been transformed 6 spaces to the right. The other way to graph this, make an x and y table and start plugging in some values. Like if I plug in a 0 in for x, I get negative 1/3 out for y. Okay, because I just plugged in the 0 right here, and for x I got 2 over negative 6. So I went through and plugged in some other numbers, and the whole point of the x and y table is that it can let you get a quick graph by plotting the points. 0, negative 1/3 is a dot there. 4, negative 1, that's roughly there. 5, negative 2, it's a dot there. 7, 2, it's a dot up there. 8, 1 is a dot roughly around there. So without a calculator, it will give you a rough sketch. You'll just probably want to grab more points if you don't have any inkling of what the shape's going to look like. So that's how you can graph this. The big reason people check out videos like this, though, is because they're looking for the domain and for the range. The domain is all the x variables, all the x numbers you can plug in, all the ones that you're allowed to plug in. So try to remember, domain always goes with x. So you look at the function and you think, what can I plug in for x that doesn't break any math rules? You can plug in 1, you can plug in 2, you can plug in 3. You can't plug in 6, though, because 6 minus 6 would make 0. So 2 divided by 0, that's undefined. So the way we can write our domain in interval notation is that you write it from least to greatest. Negative infinity, which means the smallest negative number you can think of, comma 6, and I need to stop my interval at 6 and put a parentheses because I can't include exactly 6. Then we'll put a union, and then we'll say 6, which means we're going to pick up our interval right after 6. Parentheses means don't include 6, but pick up the interval as soon as you're just one small decimal away from 6 and go off to positive infinity. So that's our domain. The range, if domain is x, then range is y. We'll give that an interval notation too. The range represents all the y values that you can get out of the function. So it's always easiest to look at the graph for the range. So go from least to greatest, just like we did with domain. The least is negative infinity because the arrow keeps going down, but then it stops when we get to 0. We can't get out y equals 0. And then it goes to positive infinity. So we want to do the same type of thing, except we're omitting 0 in this case. So I stop my interval at 0, then I put a union to show we got to jump over 0 and go off to the next ones.